Okay, welcome back. So in the previous page, we have mentioned we have to split the nodes when necessary, right? Especially in the insertion process. Then the question will be because, given the nodes as well as the index trees, we may have different ways to split the nodes, right? And we can also have different ways to partition to form them into rectangles. Then which way is a better way to split? Because different splitting may cause different kinds of results in the index tree. So for example, if we have 4 records to be inserted into our tree, and we have A, B, E, and F, we have different way to split this 4 nodes or 4 records into 2 nodes, right? Now if we can split in this way, A, B they are in one rectangle and E, F in one rectangle, then we can split them into one node and another node, right? However, if we split them into different ways, BE in one node, AF in another node, it is also one way to do the splitting, right? However, we have very different results. Then which way is better? This one or this one? This is also corresponding to the insertion we showed before, right? Before we mentioned we have DYEF into one node, and we have to split them into different nodes, into 2 nodes, right? We split this way. However, we also have different other ways to split these nodes, right? Now we can have YE and DF. This is also doable, right? Then the question will be, what is the target in the splitting, and how can we choose a better one, or the optimal one to split the nodes? So normally when we do the splitting, we have one objective, which is to minimize the total area of the 2 covering rectangles. Once we split these 4 records into 2 nodes, this is the one rectangle which covers AB, right? This is another rectangle covers EF. So the area covering AB is not this size, right? And the rectangle covers EF is not this size. However, if we split in a different way, like AF, BE, then the rectangle we use them to cover them, will be this rectangle as well as this rectangle instead, right? In other words, so compared with them, this one will be a better splitting, right? Because the area we use to cover them, AB, EF, are relatively smaller than this one. Okay, so this is what we can see. Then the question will be, do we have an algorithm which can do the splitting automatically, to select the criteria? The answer is yes, we can have a way, or we can have an algorithm to do the splitting. Let's assume we plan to split one region or one area S into S1 and S2. Then how can we do this? So when we do the splitting, normally we want to ensure the nodes which are far away should belong to different nodes instead. Because if we incorporate them together into one node, it will be a waste of space. So normally, given a region as well as records inside them, we have one initial step is to choose the candidate for the seeds of the regions of S1 and S2. How can we choose a seed of S1 as well as seed for the S2 among the instances? So we have this initial step is to choose a seed for S1 and S2. The way we do the true selection is to choose the candidates which are very far away from each other. What does this mean? We want to find the 2 candidates or 2 records. If we plan to cover them into one single rectangle, then the area is MBR denotes the minimum or bounding rectangle, right? Which is a rectangle to cover both A and B into one single rectangle, right? The area inside it. In other words, if we plan to cover AB into one rectangle, we have one region, right? And we also remove the area of A and B. In other words, this formula denotes the blank space we use in the rectangle to cover both A and B. However, we exclude the space for A and B, right? And we want to find the data instances which can maximize this formula, this term. And we can choose them as seeds for S1 and S2. In other words, these 2 entries, these 2 records, they are very far away from each other. If we put them into one single rectangle, it will be a waste of space. In other words, we choose to split them into 2 rectangles instead for S1 and S2. What does this mean? Let's assume we have 4 records A, B, E, F, and we plan to split them into 2 rectangles. So the way we do the initial step is to find 2 data instances which can maximize this term. For example, we can find A and F. They are very far away from each other. If we plan to incorporate A and F into one single rectangle, it will be this one, right? From here, the vertical line, the horizontal line, vertical line, and horizontal line, right? This will be the rectangle we use to cover both A and F into one single rectangle, right? it will be a waste of space. In other words, we can find AB according to the formula, which will be A and F. And according to the initial step, we will use A and F as seed nodes for S1 and S2. In other words, we will split them into two rectangles instead, which will be separated from each other, right? And we use A and the seed node, F as another seed node for S1 and S2 respectively. Given the seeds for S1 and seeds for the S2, then we can assign the remaining ones, B and E, into them, right? To select which one should be, we can assign them to. Then we'll do the assignment is according to the iteration step. We can choose for all the remaining entries like B and E, we want to find which group we should assign them to. And the criteria we do the selection is according to the formula of the term here. We want to maximize this term. In other words, we want to ensure if we assign like B to A, we can maximize the waste of space. We assign the B to A, it can introduce less space cost compared with assign B to F, right? According to the formula we show here, in other words, we should assign B to A instead to F, and we should assign E to F instead to A, right? And in this way, we can assign them to the rectangles and for the S1 and S2. We will have A, B as one rectangle and EF as another rectangle. In this way, we can ensure that covering rectangle will have to enlarge least compared with the other ways, right? So this is the algorithm we can use to do the separation of the nodes into rectangles in the insertion process.